My name is Andrew Penner, and I'm the president of the AE Canada East chapter. Before we get rolling today, I'd just like to give a quick shout out to our sponsors. Sponsors are really important to chapters like ours. They enable us to fulfill our mission financially, and through their support, they confirm our relevance and provide credibility. They expose our members to new ideas, new ways of thinking, and they help to grow our network and influence. What you see on the screen there is this year's stable of sponsors, and we're really honored and proud to have them working with us. Of course, we are a chapter of the Association of Energy Engineers, and the AE Canada East. As a chapter, we look to espouse the mission and values of AEE. We are the local expression of AEE, and for some, we represent their only window into the International Association. As an association, it was founded in 1977 and has grown to include more than 18,000 members operating in more than 100 countries, and there's over 90 chapters just like ours doing similar work. If you're not a member of our chapter and you're interested to learn more, you head on over to the website there on the screen and learn a little bit more about us and join if you like. And now, without kind of further ado, we're going to introduce the topic for today, which is really interesting and I think timely given what some have called the housing crisis. Certainly within Canada, but I think it's probably not isolated to Canada and certainly not to our chapter's region. So this one is really focused on residential conversions of commercial office type properties. So we have two great speakers here today from NOR to share their insights into the topic. We've got Blake Jackson, who's the Director for Sustainability with NOR out of the States, out of Boston. He's got a whole bunch of great kind of accolades to his name, a number of awards. I'm not going to read all of them, but he's been a 40 under 40 person, and anybody who gets any of those number under number, I think they've done something right, certainly within their area of practice. So I'm always pleased to have somebody like that, presenting and chatting. And of course, we've got Tobias Fellows as well. He's a principal and architect at NOR here in Ottawa. He's been with NOR for 8 years, but he's been a practicing architect for 24. So I'm going to pass the baton over to these two great guys, and they're going to talk to us about residential conversions. Take it away, guys.
Thank you.
Can we see the screen?
Yep, I think we're good to go.
Perfect. Okay. Excellent. Hello, everyone. I'm very happy to be here to present a whole building approach to building conversion projects. We've kind of assembled just some ideas and some thinking of projects that we've worked on within NOR, and some challenges and considerations that you'll face when you're doing a building conversion. We've done many of these types of projects across our several offices globally. And we just want to spend some time going through, and hopefully we can impart some information to you. We're just a little bit about NOR. We're a global firm. We have offices across Canada, the United States, and England. We operate in about 14 different sectors, including residential and public buildings. And we really take kind of a subject matter expert approach, where we draw on our global expertise in these different areas of practice, and we can bring them to any of our locations. And our locations are kind of strategically located across the regions and countries that we work in, so that we can really service all of the countries and regions through these kind of hubs that we operate within. And so today, as Andrew mentioned, I'm going to be presenting. I'm Tobias Fellows. I'm a principal here in Ottawa, working primarily in the public buildings and educational realm, but given the housing crisis and the recent kind of pivot from the federal government to really address the housing crisis, I've really started to work with my peers in other offices in Canada and the United States to look at this issue of building conversions and seeing how I can apply that to the work that I'm doing for the clients that I'm working with. Blake?
Fantastic. And my name is Blake Jackson. Thank you for the warm introduction earlier, Andrew. I'm an architect, a building scientist, and the director of sustainability for NOR. So I've been with the company for 2 years, and we are both internally facing, so looking at decarbonizing our portfolio of locations that you saw in the map on the previous slide, as well as doing the same for projects that we serve across each one of those sectors. And my role is unique in the sense that the team that I've built within NOR over the last couple of years brings together all of those locations, all of those sectors, serves all those locations and sectors, and brings together our architectural, engineering, and building science divisions to really promote integrative design, which is essentially what this presentation is about to talk about. And we'll be talking about conversions to residential, but also we'll be presenting some sort of universal concepts and some of our own personal experiences that are applicable to any types of existing building adaptive reuse projects.
And so just a little bit of a note on what is a building conversion. I think it's fairly evident. It's when we have one use and it gets changed to another complete use. So, sometimes they're referred to as repositioning projects. Previously, you may have heard the word adaptive reuse. These are all kind of terms that represent the same kind of idea where we're converting in this case, the examples that you see in front of you are office to residential conversions. Now, there's a lot of different styles of conversions, and we're working on some of those in our office. We're currently working on an old print building that is getting converted into laboratories. They could also be an office changing into a storage space or a school, or some buildings, it makes sense to convert them into hotels. They may have a particular character or style about them that makes them more relevant for a different function. But I think what we're looking at is really a phenomenon that is increasing due to COVID and other factors, where we have a glut of office space that is sitting unused, and we need to convert that to another use that's going to be in need. And obviously, globally, there's a housing crisis, so it seems like the stars are aligning for building conversions right now.
Well, in particular, with that glut of office spaces that you were talking about as well, those tend to be located in a monoculture in the best locations from transit, from access to amenities within the city. And so that's why it's also important to bring housing back to downtown urban core so we can reactivate those spaces 24 hours a day. By bringing people into the urban core, we reduce transportation emissions, potentially waste emissions, and it gives us an opportunity to focus on opportunities for the buildings to themselves decarbonize as well, through electrification and through adaptive reuse that really focuses on reducing the footprint of the buildings as they currently exist in their existing form.
Yeah, and also, I mean, I think the buildings that are looking to be converted are typically 1950, 1960 buildings, maybe the 70s. These are buildings that were designed pre-energy crisis, and 2/3 of these buildings will be in use in 2040. So they're going to be polluting all that time. So it really is a good strategy to try and upgrade those buildings and reduce the carbon emitting aspects of them by increasing their building envelopes. And it's really an opportunity to reduce our carbon through the reuse of the structure. We're reducing the amount of carbon we're making, and we're sequestering carbon within the structures that are there. And at a particular point within the rehabilitation of a major rehabilitation like a building conversion, it's a big opportunity to go and electrify our buildings like Blake mentioned. It's also, I think a really good opportunity for companies to be involved in the circular economy. Buildings go through a natural life cycle. They get built. They undergo improvements. There's ongoing operation and maintenance projects that need to be done. After a certain while, you have to analyze them if there's leaks, or other aspects of the building that needs to be repaired, and then they kind of go through a master planning, feasibility, and we're right back at the recapitalization or repositioning of these buildings. So this is an opportunity to work within the circular economy. Circular economy is good for our environment because it takes assets and elements and reuses them continually. So I think that's something that is a real opportunity for groups who are involved in these types of projects.
Yeah, and we don't mean to pick on the 50s, 60s, 70s vintage of buildings, but they were built during a very different time when the nuclear age was upon us, and the promise of cheap, infinite energy and climate change wasn't even being talked about and addressed, right? And so there's no question that those buildings and their systems, both cladding, architectural systems, glazing systems, fenestration, and HVAC and R systems are all at the end of their useful life. It does generate a unique opportunity to rethink, particularly our central business districts and downtown urban cores through a lens of decarbonization and other holistically integrated approaches.
Another big aspect of these projects is the ability for these individual projects to help regenerate our urban core. You can see in this image that there, as Blake mentioned, there's a glut of office buildings within one location. And how can we use a building conversion program to help reimagine what a downtown can be, and really look at how these projects can bring people back. I know, the government is thinking about, legislating a 3-day work week. That's going to bring people back in a particular way, but bringing them and bringing them there to live is really creating the kind of change that I think will be necessary for these areas to really thrive, with all the existing infrastructure that is already built there, and these small businesses that rely on people. I think it's really important that we take this opportunity and reimagine our downtown urban cores, and using this as a tool to reimagine them.
One of the other interconnections with this concept, and I really like this particular image because it begins to speak strongly to the size and scale of the opportunity here for cities like Ottawa and other cities across Eastern Canada for the audience here, but really everywhere, is the tie-in to sustainability and also resiliency and increased resilience in cities. So in a climate change scenario, we are having more heat waves, hotter temperatures, lower winter extreme cool, although we'll still have cold weather and snow and skiing and all those types of things. But we have to think about the opportunity to cool cities as well through reimagining this particular building stock in a way that can do that, through reintroducing nature-based solutions into sites that have cooling and passive shading strategies, as well as stormwater infrastructure capabilities. We can anticipate more rainwater in this particular climate in the future. More rain events mean more stormwater overflows and more issues with resiliency that can be addressed through including nature-based solutions and urban cooling strategies into these particular projects. And I like the juxtaposition here between the park front along the water and the downtown urban core, and they couldn't be more stark. And so there's an opportunity to weave those things together in meaningful ways that sort of challenge a 21st century urbanism to be more nature-based and more resilient and sustainable as well.
On all of our projects that we work on at NOR, we like to kind of think of a holistic approach to how we address them. So we usually try and set out principles that help guide our decision making. And so these are some of the principles that we feel that would be used in a building conversion project. I think at the top you'll see affordability. I think that's one of the big primary things of these types of projects. We need to work with the developers or building owners that are proposing these types of projects and understand their performance. They're very sensitive to any increases in costs, so we have to adjust our design and design accordingly. I think another key aspect that's impact is indigeneity. The housing crisis is unequally and unapportionately apportionately. The indigenous community is taking on a lot more of that impact relative to their population. So I think we need to really look at how we can provide solutions that address that within building conversions. And also in doing that, I think we need to think about, their traditions and whatever ceremonies that they need to take place within a residential space. We need to be sensitive to that. We need to incorporate that thinking into our designs. Another aspect is the heritage aspect of the project, or even just the art. It may not be a heritage designated building, but it may have unique architectural characteristics that we need to either preserve or be aware of, and really look at how we can work with the existing building to create something that that respects the heritage aspect of the building. The heritage aspect of the building really impacts. There's been studies done about how the heritage impact of a building can have a real financial benefit to a community. So by preserving that, by continuing that in a building conservation project, we're preserving that heritage, and cities and communities are able to reap the benefits of having a building that has a good heritage value. Obviously, we got to think about how the building's being operated, and we want to make sure that we're choosing systems that work, that have that are robust and that are cost effective, and we really look at the life cycle aspects of all the buildings that we're looking at. So that's going to mean that we need to understand how they function, and really incorporate that thinking in the design process, or in the early design processes. So it's really baked in to the solutions that we provide. Inclusivity and diversity. We're really want to make sure in the buildings that we're designing that we're thinking about universal accessibility. Universal accessibility has demands on space. It takes more space to make sure that these buildings are working for everyone. But I think a key idea that I like to use is that a universally designed building is better for everyone. We all have people that may have challenges, but I think if we can address those through design, I think that's going to make a better place for everyone. And then I think sustainability, wellness, and resilience, it's a real opportunity at a building conversion when we're converting building projects, that we're able to really look at that. And it's an opportunity at a major kind of threshold in the building where we can incorporate a lot of that thinking into the design. Obviously, we have to be sensitive to the cost of the pro forma. So we need to pick things that are cost effective, pick solutions that are cost effective, but we want to really make sure that in a major building renewal process that we're addressing those elements.
So if I can summarize a couple of things here, if we think back to the previous image, which was the aerial of downtown Ottawa, we're welcoming in voices that aren't necessarily layered into that patchwork of buildings. And it's an intricate patchwork because it is an older, more mature city than some of its counterparts further out west. But again, trying to welcome more voices in. We're trying to solve a climate crisis and a housing and affordability crisis. On the affordability issue, some of the other attributes of adaptive reuse that help us to control are construction costs and schedule. So everything is more expensive than it was before. Lead times are longer. We can be grandfathered in using existing buildings that can help us to establish mechanisms that help us to control our critical path on projects and our schedules, which is something that should be factored in when thinking about these types of projects. Another concept here that ties into a few of these is this notion of transparency and disclosure around building performance. So now all buildings are required to track, monitor, and publicly disclose their utility data, so fuel sources, water use, and in some cases, like in Toronto, this translates into taxation mechanisms. And so I imagine most municipalities are going to move in this direction. And so being able to responsibly manage finite resources is going to be a critical component in the future, and it's going to be triggering a lot of capital improvement projects. So the need to adapt and reuse all buildings, because it's the existing building stock that got us into the climate conundrum in the first place. It's not the new net zero carbon positive buildings that are going to save us. We have to do something about the existing building stock. I do want to hone in on one final key component of this, which will take us from sort of the big picture conversation down to some more specific areas of focus, which is the heritage and architectural character. So there's really two types of, in my mind, there's two types of adaptive reuse projects. There's one that would qualify as historically significant and or a heritage building, and one that is just a building that is being reused. And those are two different scopes and two different opportunities. In one case, where you're just reusing an existing building that maybe has some architectural intrigue but isn't designated in any sort of way, you have a lot more flexibility. Yeah, you're less limited by things that would be considered architecturally significant as contributing to its heritage value, which you have to preserve. So in a heritage situation, on the other hand, you're a little bit more limited in what you're able to evaluate. So understanding that very quickly, and then the potential for rebates and tax opportunities associated with heritage value within buildings is also something to consider early on in projects. I don't know if you had anything to add to that, Tobias. Sorry to.
Yeah, no, that was just the tax, but I think municipalities are really they're because buildings are sitting empty, tax base is going down, so building conversions are important to keep that tax base going. So I think that's going to be a big driver of these types of projects and the incentives that will come with that.
All right. So we're going to look at a couple of different projects in a moment that deal with each one of those types of scenarios. But in either instance, heritage or non-heritage adaptive reuse projects, we like to utilize an envelope first approach. So responding to the architecture, and it's put in another word, by responding to the architecture, you can then downsize or specify certain types of systems that are appropriate for the use. Then later layer on renewable energy technologies on site and or off site to get to a carbon neutral approach on projects. So this is fairly formulaic, and it's derivative of passive house, which is the direction that most municipalities are going within. And it's appropriate because it's a formulaic building code, not a rating system. It's very different from the ability to cherry pick items that maybe work or maybe don't on projects. It's an all or nothing proposition around ultra efficient buildings that can be adapted from new construction markets into existing building retrofits, depending on the type of and opportunities that you have available to you. So if we go to the next slide, this is just a look at that idea of sort of starting with the building project and then right sizing the program, oriented it to the building or orient it to its site and or climate, and utilizing nature-based solutions as we can do. Obviously, we can't pick up and move around existing buildings, but we can open them up to better access to daylight. We can reconfigure space planning measures in order to respond to views and climate and heat and different types of things. So by focusing on the envelope and getting it as airtight as we can, and pressurizing the building in ways that are promoting indoor air quality and insulating where we can, and maybe replacing glazing where we can, suddenly it provides us an opportunity to downsize our systems as a response, to electrify those systems more affordably, utilizing again the architecture as a passive design element itself, or an envelope first based approach. Then once we minimize those loads for those end uses as small as we can, then we can very cost effectively introduce either on-site renewables and or off-site renewables to get to a pathway to zero for existing buildings. Now, this becomes, again, more challenging the more you move towards the heritage end of the spectrum. But this is, again, an example of how an envelope first based approach can work in both a new construction scenario and a building adaptive reuse scenario as well.
Yeah, and the interesting thing about a passive house approach is they actually have a rating system. Passive House does, that allows you to upgrade a facility over time. So, for instance, if your mechanical plant is still has 10 years of good life in it, through the Passive House Enerfit program, you can you can do all of your other renovations, like your building envelope upgrades, and then you can go back and look at upgrading the plant at a later date. And this system allows you to upgrade certain components over time. So that's something to be aware of if you're looking to get into a rating system to quantify your actual project.
And so we'll look at a project from my past work here in the city of Boston, where I'm located, but I do, again, practice across all of North America. But this is a historically significant project on the National Register of Historic Places, so it would be considered heritage by Canadian standards, in the Charlestown Navy Yard. And this is a historic district and a historic building within a historic district. So we had a double whammy. And it was an existing building that was somewhat falling into ruin, that was being reimagined as a potential affordable housing complex. And so we had the juxtaposition between the historic value of the building, and you can see some of the spaces on the inside that we were forced to, well, it didn't take much logic to say, hey, we could do something really cool with this. And the idea was that this was going to become a museum to the chain forgery and the Navy Yard at some point. But we also had conflicting items that they wanted us to seal the envelope. They wanted us to electrify the building. They wanted us to raise it up because it was in a floodplain. There were lots of things that we would have been easily able to do in a new construction scenario, and yet we're limited by the heritage value of this building. The one other point that I'd like to make here is that because this building is on the National Register here in the US, 50% of the pro forma could be covered by historic tax credits. Now, you don't get them until the very end of the project, and so it's a balancing act to determine if you are in kind or in good faith preserving the historic and architectural value of the building. And there aren't very specific guidelines on what that means, because each one of these structures is unique. So we had to balance the need to meet what the city wanted, which was essentially a new construction, all electric passive house in a very leaky, old, historically significant building, which created a lot of challenges. So if we go to the next slide, talk through some of those opportunities here and on the next slide too. But basically working with the existing building to say, well, we need to evaluate what's there anyway, and what makes this historically significant versus what can we improve. And so in this case, we were actually able to add insulation on the inbound side, which did take away from some of the character of the building in terms of the exposed brickwork, but it was something that we had to do just to meet modern codes, as well as to really focus on the outside of the building, which was what was truly historically significant, particularly since we were modularizing the spaces and putting in housing units. You were going to lose a lot of that capability on the inside anyhow, and most of the value was going to be on that large nave space, which was going to be converted into a museum. We were also able to update the windows and the glazing systems to modern glazing systems, and particularly because we had a low window to wall ratio, we were able to get through the energy model double pane glazing, so it helped to control the cost on that as well. So we were also able to repoint the brick systems, seal up some of the areas, keep a lot of these types of things hidden. But again, a balancing act, working with what the existing building was there and its actual inherent architectural heritage value, and new concepts that would enable us to downsize the systems, the energy use intensity, decarbonization, and even potentially electrifying all of these units whenever we worked on the project. If we go to the next slide, this is just to compare the Chain Forge project to another project that we did with the same developer, to say that what we did for one doesn't necessarily mean it's going to get approved from the city side or the historic preservation side in the other instance. So some of these things were left to be determined. And but the point here of the envelope first approach reigns true, because if you look at how we would evaluate this from an energy modeling perspective and then also a cost estimation perspective, is we look at, well, can we alter the roof? Well, in this case, we had a historic slate tile roof. We couldn't put solar on it, so renewables are off. Upgrading the roof was off, but we could insulate underneath it. So it creates these opportunities for how we can maximize the envelope utilizing modern codes, modern building mechanisms and techniques in order to preserve the historic value. But notice we're looking at roof, envelope, glazing, window to wall ratio, which doesn't change in a historic building unless you're making an addition, and airtightness. You have to focus on that first before you go to the systems. And this is really where the work on a type of project like this begins, but it starts with the architecture, which makes me. And then also on to responsible water use. So water is artificially very inexpensive, so it's very difficult to generate a return on investment for it, but it's another utility that transparency around disclosure of building performance is requiring us to monitor, disclose, and manage. And so on projects, generally, we will be provided an opportunity to make a big water reduction impact over the baseline by looking at indoor, outdoor potable water use, irrigation systems, the potential for rainwater harvesting, which is very useful, particularly in that scenario that we talked about with increasing stormwater retention and the potential for increased resiliency, particularly in areas that are going to experience more precipitation in a climate change scenario. That's not always an opportunity for us on existing buildings, particularly heritage buildings. Sometimes you can or can't touch or adapt the site. But again, we're always looking at opportunities to meter and specify efficient water fixtures so that we can reduce that source at the point of use. And the next slide just talks about some of the specifications opportunities that just through the plumbing fixtures, we can reduce potable water use in existing buildings by at least 40%. And this is a little unfair because that would be like if we were converting it from a renovating the building from office to office. So it would be very different with more fixtures if we were renovating it from a office to residential. But in any scenario, providing new plumbing fixtures, modern plumbing fixtures that are very efficient helps us in that efficiency, as well as reducing our costs and ability to monitor and report on utility data use for both water and energy systems. And then lastly, all of this work is really predicated upon changing the way that we practice architecture and engineering. So traditionally, we've done, we design something, we fall in love with it, we get the cost estimate back, and then we have to sort of begin value engineering pieces of the building out that make it unique and wonder why things happen, that buildings just become a bit, monoculture. The idea here, particularly because we're focusing on carbon, and this is the direction that Passive House is moving, cities are moving in, green standards in various different municipalities, federal standards, even LEED version 5 is looking at carbon, holistic carbon, both embodied and operational, early in the process. And so that requires us to do earlier phased energy modeling and cost analysis so that we can use those not as hallmarks of decisions that we make, but to drive the process forwards, thinking about carbon and thinking about building performance. And so by doing this work earlier, we're able to make those decisions about the life cycle of a building so that we can strategically come in over the course of the time period which we have to decarbonize, which in different municipalities is 2040 to 2050, to say that, well, maybe we don't do everything right now. We focus on the envelope, strategically electrify some of these systems, and then in 10 years when we replace X, Y, and Z, that's when we come in. So it helps us to make those types of decisions dynamically early in the process in ways that we didn't before. So it's very important to bring that cost estimation and carbon performance modeling to earlier in the process. And this is just an example of a project where we were working with a retail prototype that stores across all of North America, looking at their whole life carbon impacts. And so this chart looks at a 25-year lifespan of the prototype facility, and you'll notice 2 bars for each year. So in year 0, you'll see the embodied carbon, which was approximately 11% of the total carbon of the 25-year life cycle of the building. This is the level of minutia that we're having to get into now, particularly with CAGBC, zero carbon building standards, and the looming specter of LEED version 5, which will be upon us within about 6 months. I believe they're going to launch it this year at Greenbuild. This looks at the baseline of embodied carbon versus the reductions that we made through looking at the specifications. And then on the operational side, you'll see from years 1 through 25, there's a big bar and a small bar. The big bar is the baseline, the small bar is the electrification and the efficiency measures that we made. One thing I'll point out is that the embodied carbon impacts are locked in place at procurement. There's these little blips at year 10, 15, and 20 in this particular client's gestation period at which embodied carbon becomes impacted because we're doing light refreshes or renovations. But this makes the argument for why it's important to bring these mechanisms to earlier in the design process, because at procurement, you lock in the embodied carbon build of a building forever. Now, in an adaptive reuse scenario, these numbers are way down. The only challenge is that sometimes the operational carbon will go up just because we're responding to weaker envelopes. So again, it's a balancing act, but it's something that by understanding it earlier in the process, we can make decisions that sort of balance it out so that we can have a total life carbon footprint of a building that we can measure, manage, monitor, and report upon for various different mechanisms. But we're thinking very holistically about the total carbon of buildings from the very beginning of projects now, as opposed to much later in the process, or worse, not at all. And then lastly, we talked about, renewables aren't a first solution. They're after you make the building as optimal as you can, because that helps to control costs and the amount of renewables that you need. And so we are a bit technology agnostic and approach agnostic. We look at the right opportunity that's available to us for the various different projects that we're responding to. There's traditional panels, there's panels over parking, there's on-site wind, there's building integrated PV. Some of them look like traditional panels, and some clients love that because it directly communicates an ethos between sustainability and the consumer. In other instances, particularly for heritage buildings, those things need to be hidden or concealed in ways. And so there's technologies that allow us to do that by either incorporating them into the roofing membranes or onto the building facades, or even the promise of solar glass, which I keep seeing examples of, but not a lot of built examples of. But I'm sure it's out there somewhere. The technology has to exist at some point. But every facade, and including the roof and the ground, offers an opportunity to integrate tastefully and meaningful renewable energy to be a part of a net zero carbon strategy.
And this is an image of another project that we've worked on in Ottawa, that we're kind of doing a solar analysis of the building to see which surfaces really offer the best payback for installing them, and which ones don't. And so through the software that we use, we can evaluate the building and give clients a good indication on where, if they were to consider solar panels, where they would be best suited. We're going to move on. We're going to just hit the last kind of section and just talk about some of the challenges and considerations, and then we'll open it up some questions after that. But I think, there are three main challenges for these projects. We've kind of touched on some of them already. Obviously, zoning is a big challenge. If you're trying to convert a building within an industrial zone or within an office, a downtown core, which is zoned for office buildings, then you're going to need to work with the city and the planning departments to, change that to make it acceptable for residential use. So I think the cities are aware of these challenges now and are working to try and streamline the process of rezoning. But it's something that has to be looked at the onset of a project, at the very beginning of a project. Also, because the pro formas are very cost sensitive, we really look at the building code, and we look at part 11 of the building code for existing buildings, and we see where we need to make upgrades and where we don't need to make upgrades. If a stair is acceptable and we're not touching that stair or doing work within that stair, then we'll leave that stair as is, and the code allows that grandfathered stair to be not touched because it's not practical to update such a major component. It's not always the case that we can do this, but where we can, we will. And the same goes for the building envelope. If we're not making impacts on the building envelope, we might not need to do major improvements. We may be just looking at air tightness or other aspects to just do a minimum intervention. And these are things that are on a case-by-case basis. You have to evaluate the specific conditions of the building to really understand whether or not they apply to you. And as we've said all along, the economics of these projects are very cost sensitive. So you really have to make sure that the project is feasible. And we do a lot of that work up front with our clients.
And one suggestion, a bit of advice or a recommendation is this is one of the instances where building science should really drive the thinking about a project, perhaps even before it becomes an actual project. So, we can do thermography, we can do blower door testing of existing buildings to determine their air tightness and areas of leakage. We can do smoke evacuation tests, particularly, or seeing is believing. And when an owner can stand outside of their building, which looks hermetically sealed, and watch the smoke coming through the cracks, it tells you the types of interventions and the types of services necessary to figure out the appropriate solutions. And again, as Tobias said, these are, one-off unique solutions each and every time. So we would definitely recommend allowing building science to determine the types of appropriate responses that should make it into an RFP and eventually a project.
Yeah, so this is a project that we've worked on. It's an older 1960 office building. It has a number of different building envelope conditions on the outside of the building. It's comprised of cast in place elements that you see in the red and in the gray. Those are cast in place elements that kind of run inside from the floor structure all the way out to the outside. And then you have precast panels with louvers, with vertical louvers. So it's a very complex building envelope with a lot of challenges. So we really, when we were studying this project, we look at elements that we call latent defects. So these are latent defects are kind of defects in the building in when the building was originally designed. This is what we're looking at here is one of those horizontal louvers. It's attached to the floor plate and the vertical wall, and it goes from the inside of the building to the outside of the building. So it's obviously a massive thermal break. So in these situations, we consider this a latent defect. We really have to study it and understand the implications of this. And it could be dew points coming in, it could be thermal comfort, it could be durability, and it could be the building envelope and the energy performance of the building. So we really kind of look at all of these things holistically and try and understand. And on the right, we kind of start from a kind of idealized scenario with what would we do in the perfect situation. Well, we want to ideally put all the insulation on the outside, but we can't always achieve that. So sometimes we start to study and we start to get more pragmatic. We say, okay, well, this can easily be done. The horizontal aspects can easily be done from the outside because we're going to be replacing some facade material, so we can get at it there. But maybe we're not replacing that facade element. Maybe we want to retain the precast, in which case we have to do everything from the interior. And so I think, looking at all of the options and being very pragmatic about what kind of solutions are going to work and going to work from a technical perspective, but also from a cost perspective, these are things that we have to do on these types of projects. So in this particular case, we recommended doing it everything from the inside, where the access is a lot more readily available to us, to the workers, and so it just made sense to do everything there, and we were able to achieve all of the energy requirements that the client had set out for this particular project. Just a few key attributes to leave on. I think, some things that we are kind of like a go no go on buildings would be the floor to floor height. You need to have a minimum of 9 feet. We need to make sure that we can fit services within within the floor plates of the buildings, and we can't compromise space. Like, we can't compromise the units. If we have ducts going everywhere within a design, maybe in some areas it's okay, but we can't have it running everywhere. So we need to make sure, because these units are going on the open market and they have to compete with other units that won't have these encumbrances built within them. So we really have to work and make sure that, a minimum of 9 feet is something that we've come to learn. And also, on an efficiency level, we need to work with at least 80% efficiency leasable to gross building. And this just means that that we're not spending money on areas of the building that aren't making money. Now, there are things to consider on different types of building or residential typologies, such as student housing, where we might be able to make some more amenity space kind of in the building core. So that might help with that leasable to gross, where we have a deeper floor plate and we're looking for uses in that core area. But a rule of thumb is 80%. And then I think, as we've been talking about all the way through, can we implement a passive strategy? Because that's where there's going to be some significant savings. If we can really, is this building suitable for some passive strategies? And I think that is something that through experience you kind of come to learn when you're evaluating these buildings.
Well, particularly for the vintage of buildings that we're talking about too. So when you're adding in, when you're converting them to residential, most of these buildings were designed to be hermetically sealed, and now we have to have operable windows. And so access to window lines become critical. We're obviously limited by where the original architecture, the window to wall ratios, the solid to void relationships, the sill heights in particular, will dictate a lot of our abilities with the system. So this gets into sort of the minimum 9 foot floor to floor as a rule of thumb. And then another point on the efficiency. So what is true for new construction is still true for adaptive reuse. The one opportunity I see here for adaptive reuse, so you had brought up, in some of the student housing spaces, that some of the inefficiency could be reprogrammed as amenity. In a hospitality scenario, it could be that Instagrammable moment in a unique space or a unique room. In a more general sense, the inefficiency that's built into some existing building repurposing could be reutilized or recouped as universal design space, to get back to one of the concepts from very early in the presentation that Tobias brought up, that it inherently requires more space to give more wheelchair accessibility to more units. And so this may be a way of helping to overcome some of those existing and inherent challenges to buildings that are somewhat more cumbersome than a new construction start over from scratch scenario, to help overcome some of these inherent challenges.
So that's the end of our presentation today. If you want to learn some more information, please, you can go to our website. We've got a couple insight articles that we've generated about office to residential conversions, and also kind of urban regeneration and the importance of building conversions to that concept. So thank you very much for having us.
That's really great, guys. Just to kind of get the questions started off here, I do have one, and it's related to making choices or determining the right approach to take with respect to a building conversions. Like in the context of residential, what would an owner look for in a building to make it ideal for residential beyond the ceiling, the floor heights, and some of those things? Like, are there limitations on how many units you can put on a floor plate? Does building code, require a certain number of windows in certain types of rooms that would be limiting? Like, what kind of characteristics might somebody look to hone in on?
Yeah, I think, and Blake can add to what I'm saying, but I think one of the main things is the geometry of the floor plate. If you start getting too deep of a floor plate, then you're going to have challenges with access to daylight. And there's different ways of addressing that. You can have interior partitions that are glazed, but in the end, I think a thinner floor plate is gonna be easier to work with and have less challenges. So I think that's one of the things that would be looking for. As far as the exiting goes, I think looking, it kind of depends from project to project. You have to look at that, something that you look at, but that's not as kind of self-evident without doing some feasibility work. So you want to do that study right away about the exiting, whether you need to add another exit corridor, because that's kind of a fundamental aspect of a project, is make sure that it has the access to exit.
Yeah, you want to bring on a structural engineer to make sure that you're not creating a scenario where you're overloading the building. Generally we don't see that happen on projects, but it is a potentiality that you have to think about. I think the biggest challenge, we're not making buildings necessarily more dense from an occupancy standpoint. However, we are distributing the plumbing chases and the electrical chases, for example, in a scenario, particularly for a conversion to housing where you have decentralized, lots of vertical shafts going throughout the space versus in a more commercial scenario where you would have a couple strategic openings in buildings. So, we hear from our internal experts that the floor plan is everything, and it's not just the depth of the occupiable units from the exterior wall and the amount of window space. We can overcome those types of challenges, and there's a little bit of forgiveness in the market inherent with the adaptive reuse on a building that understands that you had to make it work somehow. But I think the bigger challenge lies in with the hidden components of it, which are the vertical shafts and the systems and things like that. So to have a good understanding of that early on in the project is good wisdom to have and hard to gain. But a lot of times we get brought into projects to sort of determine those types of scenarios, and there's a lot of time that gets spent on just sorting those types of things out and making sure that you can put holes in places. And it's a bit of coordination, but it's certainly not insurmountable.
Yeah, Ron, that's good insight. In terms of taking and adapting older buildings, I mean, you pointed to this earlier in the presentation, where we're talking about buildings that are a handful of decades old, for instance, that the mechanical and electrical systems may be approaching end of life, but the structure still has some time in it. But does the region where the building has been constructed play a bit of a role? Like, what would you do in a active seismic zone, for instance? Is there a tipping point where the cost to bring a building up to current code for seismic or other considerations, removes it perhaps from
Yeah,
your kind of bucket of potentials?
I think it's well. First of all, obviously working with a good structural engineer when it comes to seismic, but um, there are in Ottawa, we often face this is the seismic issue, and are we compelled to bring it up to 100% of the seismic standard? I'm not an expert in this field, but I know that there are provisions within the code that allow you to just look at the life safety and not necessarily having it remain intact as a building after a seismic event, so that can lessen the seismic requirement and the cost. So you're not having to bring it up to 100% of the seismic requirements. You're just looking at making sure that individuals can safely exit a building after a seismic event, which is different. It may undergo some pretty big some damage, but you've got the integrity of the exits that allow people to exit. So I think there's some strategies there that can be deployed, but obviously it's going to be a major factor if there is a seismic intervention. That's going to have to be accounted for. Blake, I don't know if you had anything to add.
Well, it's just thinking about that. It's similar to how the energy codes would be handled in a scenario like that. So if we were designing a new construction project, we'd need a passive house wall to be able to get through the new codes, something like a R26 to 30, potentially, just throwing some numbers out there from some recent work. But we're not going to have a scenario like that in a heritage building, particularly. So if it's limited by the type of images. If it's an older building of just a few decades, but there's no architectural significance to it, then we can run the gamut of possibilities to bring that up to a modern code. If not, then it's not available to us, and we just treat it as a part of the building fabric that's always been there, and then we make up the difference with the types of systems that we specify. So I think with the seismic issue, it's kind of similar. The way that we handle energy is, depending on what is quote unquote grandfathered in, gets to have a lot of say in the overall outcome of the project.
Yeah, and then another factor on the energy side is the grid. Are you working with the clean grid or is it a dirty grid? So across Canada, we have different qualities of the energy that we have. In Quebec, we've got a very clean grid. It's all hydro, well, not all, but hydroelectric power. So it's a clean energy. So that may impact the decision to go with certain energy solutions.
Yeah, for sure. Okay, that's really interesting too. Maybe this pull the conversation up to a bit of a higher kind of elevation, and we have a glut of buildings in many urban cities, particularly with hybrid working environments and the kind of some of the perhaps the benefits that we saw coming out of a pandemic situation. Should conversion strategies like this be developed, do you think, at maybe a municipal government level, where some strategies on number of conversions, in a block area, for instance, are somehow dictated? If not, do we run the risk of potentially, over converting office space to residential and then not having, working locations in those urban cores? Like, what are your thoughts on that?
Well, I think that we're at crisis mode right now. Our downtowns are and the businesses downtown are really suffering from the impacts of COVID and people working from home. And so I think we have to look at a number of types of solutions to address that issue. And in a way, I think it's a real we're in a time period where a lot of these challenges are all kind of presenting themselves at the same time. So it's a big opportunity for us to really transform our downtown, our urban centers. And so I think that within the powers that governments have, they have their own infrastructure that they can look at themselves, and they can convert those. They should be looking at their building stock. I know the PSPC right now is looking at studying what aspects of their portfolio could be converted. So I think that it should be done, and there should be a number of strategies done simultaneously to really address our downtown cores, because I think those small businesses and the businesses down there, once they're gone, it's going to be very hard to get them back. So I think it's a number of different things. I wouldn't say that there should be some sort of hard number about building conversions, but I wouldn't be worried about losing too much office space, because all of our cities were designed based on the automobile. So it's really an opportunity to correct that. Is we can bring people down to these areas, make them more holistic and like live work play type of environment. And yeah, I think it's just more of an opportunity, and kind of look at it from that perspective.
Well, and we've talked a lot about the primary uses of buildings, but most of the downtown urban core buildings are mixed use, right? So we haven't spent a lot of time talking about that public realm layer. And that's the piece that is disintegrating right before our very eyes. And if, that's the big, if there's no office workers in the central business district, which was primarily single zoned in most urban cores, then what happens to the businesses, right? It's a better scenario to have people residing in the center of the city than it is to have offices there, because they're only open a finite amount of time and most of the businesses respond to that. And so when you go into many urban cores, certain precincts of the city are completely dead on the weekends and nights. And by getting people to live there 24 hours a day, you're curbing time and cost for commute. You're providing an opportunity for those retail environments in that public realm space to be active for more periods of time and for longer throughout the year. And eyes on the street and people on the street is what generates that economic driver for those businesses that generate a very rich and vibrant public realm. So I agree with Tobias. I don't think that we're going to have a housing shortage. It always amazes me that there's glass skyscrapers going up all the time, and you hear about 30, 40-year housing shortages. And so there's always housing shortages and more people moving into cities and being born every day. So we have to have places for them, and office spaces isn't necessarily for all of them. So, if there ever was a pendulum swing where we needed more offices, they'd go up like that.
That's fair. I think the market would drive that for sure. No, it's been really interesting. The last question I have is related to dollars. So I guess what I'm curious, from what you've seen in the marketplace, when you do a conversion, would somebody be expecting to see like the cost per square meter or square foot about on par with new construction, or are we talking about savings, or is there a little bit of a premium to make reuse kind of a central piece of your project?
That's a good question. I can definitely find out more about that, Andrew. But my sense is that that it's probably on par, because there are certain things you have to do. Like you have to do demolition, so that you have to. There are other things that you have to do. So there. I don't have I can get some information about that. I don't know, Blake, if you are.
We've seen it somewhat pencil out as even. I mean, because you're not buying a lot of raw materials, but you are buying a lot of in many cases hazardous materials mitigation. And so lots of asbestos, lots of PCBs showing up in this particular vintage of building. It takes more time to work in these spaces because you're somewhat confined. And so the safety is an issue. Access to the site is another one. Do you have the ability, in the scenario that Tobias showed with the three options for the insulation for the existing building? One of the things that popped into my mind while I was looking at that was, if you're in a downtown urban core scenario, do you even have a site to put a crane in to be able to do this type of work, depending on the height? So you save in some areas, you overspend in other areas, and so it tends to kind of balance itself out.
I think that's a good and important point to kind of close on, because, so much about our society is built around profiting and, the economics of any of the things that we choose to do, whether it be work or play, or just plain old living. So understanding and knowing that perhaps these conversion projects, aren't a whole lot more or at all more costly than building from scratch. I think the inherent it sounds to me anyways, and I also agree that the inherent savings in embodied carbon and in how we contribute positively to kind of reducing resource strain, I think puts these types of projects perhaps at the forefront. So I wanted
Just
to
one more
thank.
thing. Yeah, one more thing there. We should mention is this, that many of these types of programs get tax incentives as well. So that's where there might be a balancing out of doing that. So I think that's something that's important with these types of projects, is the government is keen to have these areas be economic drivers. So they'll provide some tax incentives. So people doing them should look into that.
Well, and also cities are tending to grow. So we're taking down a lot. We're not just taking down fossil fuel infrastructure in some areas, we're also taking down roads and ramps and things like that that open up urban space to development. And a good way, a project like that, and I've worked on a couple, always need a good urban catalyst to get people on the neighborhood so that those businesses and that public realm can take over and it generates the value that, brings the new construction in around some of these blighted areas. And so existing buildings, particularly some of those that are falling into ruin, like the one that we showed early in the presentation with the Chain Forge project, are ways at helping to foster that and also to preserve some semblance of the memory of that place, which people, which has kept people there in this case for hundreds of years.
It's also a very important point to bring up, right? There's cultural significance to our built environment, and sometimes a tremendous amount. So I wanted to thank both of you for making the time today. Of course, coming off of a long weekend in Canada, sometimes it's hard to get out of bed the next day and get to work, let alone share ideas more broadly. But I do appreciate that you both made the time. I love some of the points you've brought to the table, and I've really enjoyed the conversation that followed. So thank you to both of you.
Likewise, and thank you for having us.
Wonderful. And if anybody has, any follow-up questions, burning or otherwise, the gentleman put their contact information on an earlier slide, and we would encourage and invite you to reach out, join their network, and continue to be inspired and engaged. So thanks again to everybody for tuning in, and for Blake and Tobias for sharing their knowledge and insight with us. And we'll look forward to the next set of webinars coming out in the fall.
Thanks, Andrew.